Okay, hi guys. So in this lecture, we'll be continuing on seeing more on rate of reaction, and then we'll be seeing the rate law. So first, let's get started with rate of reaction. So rate of reaction was simply written as R equals to minus plus 1 upon gamma I into 1 upon V dNI by dt. I hope you can relate why can we write the rate in this form from the previous lecture, in which we saw that we wrote 1 upon stoichiometric coefficient times d of concentration of, let's say, product reactant A by dt. This was concentration, so I am just converting the concentration in moles and dividing it with by volume, so it would also give the same formula. Okay, so here we can write that 1 upon gamma I can be written as, rather the gamma I is nothing but stoichiometric coefficient okay, and dNi by dt is change in number of moles. Okay, so now we can say that if volume is constant, then we can write that R equals to minus plus 1 upon gamma I into 1 upon RT d del pi by dt, rather just write dpi by dt. Let's not go there. So we can directly write dpi by dt. So why can we write it? That we know that p upon RT can be written as an I upon V. Okay, so from this we can write that 1 upon V dNi by dt can be written as dP by RT dt. So from here we can put the value of 1 upon V dNi by dt as dP by RT dt. So I'm just putting the value of dPi by dt here. So R can also be written as this. Okay, next let's discuss rate law. So rate law is the representation of rate of reaction in terms of concentration of reactants. Representation of rate of reaction in terms of concentration of reactants. And secondly, we can write that rate law is a mathematical expression which correlates rate of reaction with rate constant and concentration of reactants. Rate law is a mathematical expression which correlates rate of reaction with rate constant and concentration of reactants. And we can also write that rate law is based on experimental observation and facts. Hence, we cannot write rate law expression without performing experiments. Experimental observations, or facts rather, and we cannot write rate law expression without performing experiments. Okay, so now let us see some of the ways in which we can write rate law. Rather, the representation of rate law can be written as, suppose reactants are converting into products. So now we can say that rate is actually K times R of R to the power, which is the concentration of reactant, to the power X. And X is the order of reaction. Okay. Hence we know that R can be written as, already we know that dr minus dr by dt, which is the rate of disappearance of reactant, divided by stoichiometric coefficient, which is 1, which should be equal to rate of appearance of product, which is dp by dt, divided by the stoichiometric coefficient of product, which is 1, which should be equals to K times concentration of reactant raised to the power X, which is X is nothing but order of reaction. So now we can write expression by equating all of the three. Okay, so if we have some reaction like A of A plus B of B gives C moles of C, then we can see that rate would be proportional to A to the power X and B to the power Y. Hence we can write that R is equals to rate constant multiplied with A to the power X and B to the power Y. And X and Y now will be called partial order of reactions. Partial order. And overall order can be written as, overall order, let me represent it with N, would be equals to, N is nothing but total order, can be written as X plus Y. This would be the overall order. So we can write that X is order with respect to reactant A, Y is the order with respect to reactant B, and K is the rate constant or velocity constant or specific reaction rate, but generally we say it as rate constant. K is rate constant or velocity constant or specific rate constant, specific reaction rate rather, specific reaction rate. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on the rate constant and the rate of reaction, and we'll be seeing more on rate law as well. So till then, good luck and goodbye.